I called that video Randomized Block Design Explained Perfectly, the previous one. I felt like, man, once I saw that, I'm like, all right, I get it. Randomized block design. So now we're just going to go throughout the textbook explains it, which is not perfect. And if this video confuses you, like you could click on the link, like if you're watching one of my videos. So I'm just going to illustrate that here. Let's watch it. If you're watching one of my videos
Okay,
and
so
you're like, okay, that's cool. It should, like, you could go to this link here, Professor
learning
McLeod,
about
and then you could go to
computers can be fast.
playlists, and then you could go to Statistics 101, and you could click on that, and you could go to the previous video. I'm just looking at like all my different videos here. Oh, those are my different playlists. Um, that's cool. All right. So I need to go back here for that. So now we're going to see how the textbook explains it, which is not perfectly. It talks about experimental units are the objects of interest in the experiment. And we had this deal here. Let me get it. And let's just see if it has some of that terminology in it. Here it is. Let's do that. Do I need this? I guess I could always open that up again. Woo! And so experimental units, I like to think about this. There's experimental unit, right? And so we also had this terminology. So you can pause the video and you can read that terminology. We've been through that. So an experimental unit is the object of interest in the experiment. Okay. A completely randomized design is an experimental design in which treatments are randomly assigned to experimental units. Yeah, we kind of went over that in the previous one. So we have factors, aka treatments, and they're randomly assigned to experimental units. And when you do that, it's called completely randomized design. And then you measure what are the outcomes. So if we wanted to see like what is the impact of diets, different diets on weight loss, the treatments would be the different diets. The factor would be diets. The treatments would be the different diets. And those would be like, I don't know, keto, Mediterranean, like fast food. And those would be different diets. And you assign those treatments randomly to people, which are called experimental units, weirdly enough, in statistics. And then you measure the outcomes. Did some treatment actually lead to weight loss? That'd be a horrible study because there'd just be like all kinds of random stuff. I don't know. How could you control it? There are ways. So completely randomized design is an experimental design in which the treatments are randomly assigned to the experimental units. If the experimental units are heterogeneous, blocking can be used to form homogeneous groups, resulting in a randomized block design. Okay, so heterogeneous and homogeneous. I always think of a homogenized milk. Let's just go look at it. Homogenized milk. Right? So, here we go. And did I need to respell that homogenized? Now let's look at the images. So here's homogenized milk. And when you look at milk, right, it like says homogenized on it. Homogenized. And that just means they got it up to like a high temperature with milk. And with that high temperature, I wonder if these say homogenized. Oh, now I'm shopping. It funny how quick that could happen on the internet. And so it kills like stuff in the milk. And cons. If not, it's not proven. Still, you have. I don't know what all that stuff is. Who cares? Anyhow, it makes the milk more the same all the way throughout the milk. Right? Gets rid of any little bugs, potentially even healthy stuff. And heterogeneous means that it's different. I think. Let's define it. Heterogeneous define. It's funny, you start questioning stuff and you're like, do I really know that? Diverse in character or content, heterogeneous. And we could ask, ChatGPT, because I think it's interesting. What does the prefix hetero mean as in, and let's just, I don't want to type it, as in heterogeneous. And also do tell me about homo as in, and I know that is another term, but no, yeah, it's fine. Homogeneous, genius, right? We're just learning terminology here. I just feel like in our politically correct day and age, you have to be like careful anytime you start talking about, some of these issues. Heterogeneous comes from Greek meaning different or other in context of, so hetero, different or other. context of heterogeneous, it refers to something made up of parts of elements that are different from one another. For example, a heterogeneous mixture might contain distinct substances that don't blend uniformly like a salad or a mix of sand and iron fillings. On the other hand, the prefix homo is derived from Greek meaning same or similar. Homogeneous describes something that is uniform throughout. A homogeneous mixture, like salt dissolved in water, appears the same in every part of the mixture with no distinct layers or separate components. Hetero emphasizes diversity, homo highlights uniformity or similarity. It's kind of cool to learn those terms. So here we go. So in experimental units that are heterogeneous, right, where it's different, right, the experimental units are different, the people are different. So the experimental units, aka people, that's so wacky, right? Statistics, the language of statistics, are heterogeneous, right? Because, you know, aka different, okay? Like, look at the distances we have to go to understand stuff because they're using highfalutin language, ladies and gentlemen. Highfalutin, define. And that's not spelled correctly. Highfalutin.
Highfalutin.
It's pompous or pretentious. So you don't want any highfalutin jargon. I kind of like highfalutin. If the experimental units, aka people, are heterogeneous, aka different, blocking can be used to form homogeneous groups, aka people that are the same, e.g. have less variance. Okay? Boom, boom. Resulting in randomized block design. All right, so really what this is saying is if you got these flight controllers, like in the example in the textbook, we're dealing with flight controllers, and this is like, you know, the introduction to it right here. To illustrate, let us consider a stress study for air traffic controllers. So if you got these flight controllers, and where'd our little notes go? Is this really, we're on the first slide? I can't believe it. You know, and these flight controllers, these people are different, like they're significantly different in how they deal with stress. And that means we're going to have a lot of variance in stress. And some people are like chill, low key. Like I knew somebody, like no matter what was going on, most like stress-free person ever, right? Like they got more calm as things became more stressful. They was like, it's fine. We're going to be good. So you're going to have people that are different, and if these flight controllers respond to stress differently, right, we're going to have a lot of variance, and a lot of variance down in our MSE, which is the within treatment. A lot of variance there is going to give us a large number down here, and a large number down in the denominator will give us a smaller F value, potentially unnaturally so, leading us to make a conclusion that there's no difference. There's no difference in the means. You know, the null hypothesis, no difference in the means, and we'll say do not reject. This is covered in the previous video. And really what we needed to conclude is that there is a difference in the population means and we need to reject. So that's what all that says. Here's how ChatGPT, oh, I put it here, that's so nice, explains factors, treatments, experimental units, and completely randomized design, and there's that cool picture we already looked at. ANOVA procedure. For a randomized block design, the sum of squares total is partitioned into 3 groups. Okay. Treatments, blocks, and errors. And so there's that formula that we talked about in the previous video. And the total degrees of freedom is nt minus 1 are partitioned such that k minus 1 degrees of freedom go to treatments, and the treatments are going to be your numerator, and b minus 1 go to blocks, and k minus 1 times b minus 1 go to the error term. Good luck figuring out what B is. Like, I wish they just give you a little every time. Here's what those different things are. So here's like kind of how it lays it out for randomized block design. Yep. So we saw how to apply all that in the previous one. And then it gives you the example, and then broke out factor, treatments, blocks, and response variables. So you could call the controllers, you could call them blocks. And you could also call the controllers experimental units. So just multiple ways, because statistics is jargon soup. And so controllers are blocks when you're doing randomized block design, and they're also experimental units. Will you please get me those blocks? Bring those blocks in here. Do you mean you want to bring in the air traffic controllers? Yes, bring in the experimental units. We're ready for them. You know, it's like, what is this? It's ridiculous. Anyhow, I guess you need that framework for thinking about stuff, but I just have a little bit of frustration that there's so much terminology and they have the same words to refer to different things. That's okay. Example, so here's the data, and then here they calculate their results, and you know, so that's what we did in the previous video also, but we did it our way because to me that's confusing. And then here we have our ANOVA table, and I haven't checked these actually against mine. So they got 5.53, and so for 5.53, that's what we got. So we'll just kind of like 5.53. So they must have done it right. And because I, you know, found errors before. And then they have the rejection rule, and then here they do, you know, and conclude that the population mean stress levels differ for the 3 workstation alternatives, right? So they rejected the null hypothesis. And here's where they say that we reject HO. So we'll highlight that. All right, so that's how they did it. And then they provide 2-factor without replication. I'm just seeing if we want to preview any of this Excel stuff. And you know, and so then they show, let's see if this is the same problem. I'll figure this out and decide if I want to show it to you after this video. All right, that's how the textbook presents randomized block design, which I think is kind of confusing. So if you're a little confused by that and you missed the previous video, make sure you click on the video like you saw in the beginning of this one, go to the playlist, go to my channel, go to the playlist and find that Statistics 101 and watch the previous video, which is going to be called something like Randomized Block Design, Perfectly Explained, and it's going to be video 13i. And I like Perfectly Explained better as opposed to Explained Perfectly, so we're going to switch that. But that's the previous video for you. All right, see you in the next video.